minus 6x plus 8 equals 0. So we have 4 different methods of solving quadratic equations. Of course, I'm not going to complete the square. Of course, I will not take the square root. So if factoring doesn't work quickly, I will do what? I will use? Good. But I'm hoping that I can easily factor this so I can get it done. So how do I factor?
X minus 2 and x minus 4.
Very good. X minus 2, x minus 4. So then x equals and x equals. Very good. So the ordered pairs that I just determined are?
2, 0, and 4, 0.
Very good. Thank you. 2, 0, 4, 0. Perfect. The next step is number 5. What do you think the next step would be? The Y-intercept, which will always exist. That's what we need to do for any function. So how do I determine the Y-intercept? Set x equal to 0. Let's do that. Bless you. Okay, so f of 0 is 8. So the ordered pair is? Very good. 6, 7, and 8. Any parabola has an axis of symmetry. We're not talking about a function being odd or even. It has a vertical line passing through the vertex. And this side will be symmetric of this side with respect to the axis of symmetry. Same thing here. So it's the vertical line passing through the vertex. So the axis of symmetry is the vertical line passing through 3, negative 1. Which vertical line passes through 3, negative 1? Yes, x equals 3. Very good. Any questions? Go ahead, Danielle.
No, I'm behind. You can.
But I can go back if you have any questions.
No, I was just drawing. I was still finishing up drawing the different graphs.
Yes, then these are true for having a maximum. So if the function has a maximum, it has still the same 3 options.
Okay.
One with no solutions, one with one solution, but it's a double solution, and one with 2 distinct. But all parabolas have an axis of symmetry. Okay. So since this function has a minimum or a maximum? Very good. Min value of f of x is, can anyone tell us? The minimum value of f of x is? Very good. Awesome. We know that. And the range, and you can say you haven't even graphed it. True. But we already have it in our head already. Thank you so much, Deborah. Absolutely. Good. That's all we need. Yes?
So the axis of symmetry is always just the x value of the vertex?
The line passing through, yes.
But it will always be.
Yes, okay. Correct. Okay, so let's graph. So the vertex is 3, negative 1. One, 2, 3, negative 1. I have to plot the vertex first. Then I will graph the axis of symmetry, not as a solid line. It's not part of the graph. It will only help us keep the graph in shape, symmetric. Okay, then I have to plot the x and y intercepts. So 2, 0, 4, 0, and 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And here's the parabola. make it as symmetric as possible. My graph will never be perfect, but I have to write next to it what it represents, so I don't forget what I graphed. Any questions? Any questions? Let's look at the other one with a completed square. Let's say 20 on page 360. We are given f of x equals x minus 3 squared and plus 2. Is this a quadratic function? Good. So this we know very well. It's x squared shifted where? Careful, not yet. Order of operations. Right 3, and then? Good. Will it intersect the x-axis? No. What is the vertex? Exactly. So I can immediately identify 3, 2. So now I can go back where I said I'll come back. So I'm coming back. That's the vertex. Is it easier to determine it in this case or in that case? The second one, because it's already completed. The square is completed. So I can identify the x coordinate of the vertex and the y coordinate of the vertex. But that will not always happen, right? We're not going to be given that form at all times. So now let's start again from scratch. Number 1, domain. Very good. Number 2, we already know the shape. Minimum or maximum? Here's the leading coefficient. Yes, a equals 1, so the parabola has a minimum. Number 3, the vertex. Yes, 3, 2. Number 4, x-intercepts, if they exist. If they don't exist, I don't want to spend my time on that. It's a waste of time. So do they exist? No, none. Forget about them. They don't exist. Because the discriminant is, then they exist. It's the vertex. Correct. Because b squared minus 4ac is less than 0. That's why the parabola does not touch the x-axis. I cannot find x-intercepts. Perfect. Number 5, y-intercept. There is no doubt that the y-intercept exists. How do I find it and what do I write? F of 0. In order to find the y-intercept, I have to make x equals 0 because that's the y-axis, x equals 0. So let's do this together. 0 minus 3, negative 3 squared, 9 plus 2. That's it. So one more time, what is the ordered pair that represents the y-intercept? 0, 11. Thank you. Is everyone with us?
So can you tell me why there's no x-intercept?
So let's do this again. X squared. Where do I shift it? This is the graph of x squared at the origin. Where do I shift it for x minus 3? No. To the right 3. And then?
Oh, okay.
Better? Very good. I know I look silly doing that, but I'm hoping that you will remember.
Can we do the
Yes.
down 11 again?
Yes. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 plus 2, 11. I have to find f of 0. Is that okay, everyone? Better? Okay. Number 6, 7, and 8. Axis of symmetry. I didn't mean to choose the same type of x. Okay. Minimum value is perfect. And the range, please, although we haven't even graphed it, we know the range. 2 to infinity. Awesome. That's it. That's all we need. We start by plotting the vertex. 1, 2, 3, 1, 2. We have to draw the axis of symmetry, although it's not part of the graph. It will only help us keep the graph symmetric. X equals 3 again. And now, 0, 11. Oh, no, I'm going to change the scale here. Oh, I can't right now because I put 2 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, fine. I'm going to plot another point 3 units away so I keep the graph in shape. So this is it. The distance between these two equals the distance between these two. And this is the graph of f of x equals x minus 3 squared plus 2. I like to look at a word problem. Any questions about graphing a parabola? It's a little bit more detailed than what we did in transformations, because in transformations we were not asked to present an accurate graph. We're asked to quickly identify the shape and present the transformations. But here we identified and we know everything about this function. There was absolutely no secret whatsoever. Okay? So let's look at a word problem. On page 361, let's look at 60. A ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x, in feet, f of x, in feet, is given to us as negative 0.8x squared plus 3.2x plus 6. So these models are why we talk about quadratic functions. X is the ball's horizontal distance. So x, horizontal distance. This is the height. So imagine I do this. I'm going to run after my marker in a minute. I'll do this. And this is a quadratic function. I just created the trajectory is a quadratic function. So you saw my marker went up and onward. So let's say I threw it from this height. And obviously this is what? Very good. Maximum. This is the horizontal distance till it gets to a maximum height. And this is the maximum height. And this is the distance from where I was standing and where it hit the ground. Maximum distance. Okay, so let's read the problem one more time. A ball is thrown upward and outward from a height of 6 feet. So this must be 6 feet. I'm not 6 feet but tall, but that's what it says. Where x is the ball's horizontal distance. So this is x, and this is f of x. Where x is the ball's horizontal distance in feet from where it was thrown. Okay, what is the maximum height of the ball, and how far from where it was thrown does this occur? How high does it reach, and how far is that point from the moment, from the position where it was, from the spot it was thrown? Let's look at the function and analyze the function and say, oh, I know, this is a perfect. Does it have a maximum? Because I graphed this, but does that function have a maximum? Why? because the leading coefficient is, and make sure that this is in descending order, because it may be tricky and it may not be presented in descending order. But now this is in descending order. The leading coefficient is negative 0.8. So therefore, because the leading coefficient is negative, so A equals negative 0.8, less than 0, the quadratic function has a maximum. So this works. Then my next question to myself is this: how do I determine the maximum height? What do I have to do to determine the maximum height?
Find the Y value of the vertex.
I have to find the Y value of the vertex. Very good. But can I find the Y value of the vertex before I find the... In other words, this is the Y-intercept right here, 0, 0, 6, right? So can I find a Y value of a function before I find the X value? No, I have to find the X value first and then the Y value. Good, so how do I find this X value? And bottom line, what am I trying to determine? When I'm asked to find the maximum height and how far away from the spot I threw it up in the air that occurs. How do I find that? Exactly. That's all I needed. Thank you. But in order to find the vertex, I have to find what first? The what of exactly, which is, remember from the quadratic formula, everything
Negative B over 2.
negative b over 2a. Negative, what is b? 2 times a. Negative 1.6. 3.2 divided by 1.6 is nice, which means it's, so it's 2. Very good. So negative b over 2a is 2. So the vertex has 2 times a. 2 times 0.8 is negative 1.6. That's okay. Good. So now how do I find the y coordinate? So this is 2 feet. But I'm interested in this now. How do I find that height? Very good. So I have to find f of 2, which is negative 0.8 times 4, plus 3.2 times 2, and plus 6. How much do we get for that? I'm charging this calculator. The battery kind of thing died. How much? So I don't think I need the calculator. So this is negative 3.2. And this is 6.4. And plus 6. So this is 3.2. So this is 9.2. Correct me if I'm wrong. I got 9.2. Is that okay?
Yes.
Part B. How far does the ball travel horizontally before hitting the ground? How far does the ball travel horizontally before hitting the ground? So what do I have to do this time?
X-intercept.
Very good. So this was part A. And part B, I have to find the x-intercepts. Of course, one of them appears to be negative, which I don't care for, but the other one will be a positive value. How do I determine the x-intercepts for this function? Said y equal to 0. Very good. But y is negative 0.8 x squared plus 3.2x plus 6 equals 0. What type of equation is this? Okay, perfect. There is one thing that I want to remove, which is the negative leading coefficient. I refuse to solve a quadratic equation, but that's me. I refuse to solve a quadratic equation with a negative leading coefficient, which means I will multiply both sides by negative 1. 0.8x squared minus 3.2x minus 6 equals 0. And then I will use the quadratic formula, of course. I will not try anything else. Let's stop for a moment and see if you have questions for me. Any questions? Is this okay so far, everyone? Yes? Okay, so let's take a look. Negative b plus or minus b squared minus 4 times a times c. Since c is negative, I'm going to change this in order to avoid nested parentheses. And 2 times 0.8 is 1.6. So there is a negative from the formula, but so it's negative 4 and times a and times c. But since c is negative, I change this into positive so I don't have to worry about it, about too many parentheses. Any questions before I continue? Any questions? Is this okay? Okay, so now let me show you how I would do this with a graphing calculator.
Would it be 3.2 squared?
I'm sorry?
Would it be 3.2 squared?
Yes. It's 3.2. Say it again.
No, it just 3.2 is not squared. I didn't know. If you're supposed to.
But it is squared.
Oh, it's not. Okay, I thought negative, like the outside was squared.
I don't want to see a negative in there because it's b squared no matter what b is. If I see a negative here, I will start crying because you have to square it. No matter what b is, when you square a number, it will be positive. This portion can be negative, but this portion will never be negative, correct? Okay, perfect. So let's take a look. Actually, I wanted to show this too. I will put parentheses around the numerator. We discussed this before, and I will put parentheses inside the square root. So careful on that. So left parenthesis, and I have 3.2 plus the square root, parentheses again, 3.2 squared, and plus 24 times 0.8, I multiplied. 6 times 4 times 0.8. Close the parenthesis, go outside of the square root, close the other parenthesis, and divide by 1.6. Any questions, ladies? Yes. Danielle, go ahead.
You're just plugging into the quadratic equation, right?
In the quadratic formula, yes. Yes, yes. Then I expect the other solution to be negative. Let's see.
Push second and then do that. It's like a shift.
Really?
Like it goes all the way over.
Oh, so it's easier to go backwards. Yeah, thank you. Very good. So it's expected. This makes no sense, right? Because it's behind us. So, or behind me before I threw the ball up in the air. So the distance, the maximum distance is x equals 5.39 feet, and x equals negative 1.39 feet is not what we're looking for. So this distance is 5.39. Any questions? Any questions? Is this okay?
So that's how we got the x-intercept.
That's how we got the x-intercept, by setting y equal to 0. Is that okay, everyone?
So you said even when it is one x-intercept though, you write it as like 2? Like
Yes.
earlier you were saying.
Yes. So x minus 1, everything squared equals 0, has two solutions, x equals 1.
Okay, okay,
Yeah, that's what we did in chapter 1.
right.
And you'll see what happens in this next section in 3.2. This is extremely important. Okay, part C. Graph the function we already did. So the graph is up here. I didn't graph it exactly, but we have the idea. Any questions? Any questions? Is this okay? Okay. So in that case, I'd like to move on. Let me know if you'd like to.
So if it's,
Yes?
when you talked about, like, can you do that?
Yes.
When you talk about x minus 1 squared equals 0,
Yes.
Like, wait, would that be the time that going backward? Like, because I don't know where that.
This was a question. This was a question.
Kelly's asking.
No, Candle asked, yeah.
Oh, okay. And she was showing me that, like, even if it's long enough, it's still.
This is exactly what I'm going to do next, actually. That's just this. Any questions? Is this okay? Okay, so let's move on to, we're not going to be able to finish 3.2 today, but we can move on. Polynomial functions of higher degree. Like 3, 4, 5, 6, and so on and so forth. Okay. If we know how to graph and we understand how to graph degree 3, we will have no difficulties with 5, 7, 9, 11. Any odd degree will be the same. Once we understand even degree, we will have no problem with any polynomial of even degree. We just have to understand the difference. Okay, so if you remember for quadratic, I want to work on by comparison. And third, fourth, fifth, sixth, and so on and so forth degree. Because I would like you to understand the difference. So in the quadratic, we had domain, we had shape, we had vertex, we had x-intercept, of course, if they exist, 5, y-intercept, 6, we had axis of symmetry, oops, we had max or min, and we had range. So let's see what transfers over and what does not. This, of course, transfers over, which we know from the get-go. What is it? It's all polynomials. Shape, kind of. Kind of. Instead of shape, we really will be looking at end behavior. We have not discussed this yet. It's very simple. Vertex, never. The vertex is characteristic to quadratic and no other function. X-intercept, yes. Y-intercept, yes. Axis of symmetry, never. This is characteristic to quadratic and no other function. Max, min, yes. Range, yes. So please remember, whenever we talk about the vertex, we are talking about the quadratic function. If we are talking about the axis of symmetry of a parabola, we are talking about a quadratic function. Okay, so let's see what else is here. Number 3, degree of the polynomial, because it can be odd or even. Number 4, maximum possible number of turns. By turns, we mean max min. Five, so maximum possible number of turns, which means a turn. By a turn, we mean a maximum or a minimum. Of course, max min, but this time we cannot do it by hand with TI-84 or any other calculator. 6, x-intercept. 7. This is something we have never discussed. Multiplicities. Multiplicities of the x-intercepts. Multiplicities of the x-intercepts. 8. Symmetry. We mean odd or even, if that's the case. Here I recommend a table of values or ordered pairs. And of course, range. It's a lot more work, but you will see it's not difficult. So I'm getting into those 6 minutes. If you can stay, please stay. If not, I understand. Because I promised not to show anything new within those 6 minutes, I will choose another problem from quadratic, and I will leave this for next time, for Thursday. So let's practice with any other word problem from the quadratic functions. So I'm going back. Yes. So problem 61 on page 361. Among all pairs of numbers whose sum is 16, so pairs of numbers whose sum is 16, okay. Find a pair whose product is as large as possible. Maximum product. What is the maximum product? So give me two numbers, unknown numbers, whose sum is 16. Create an equation with two numbers that are unknown, whose sum is 16. What would you say? But the sum. X plus y equals 16. So this is the sum. This is a pair of two numbers, right? Whose sum is 16. Agreed? Okay. Now I need to create the product. So can anyone give us the product of these same numbers that we used to create the equation or write the equation x plus y equals 16? So what is the product of these numbers? How do I write it?
X, Y.
Very good. It must be xy, right? If the sum of these numbers is x plus y, their product must be xy. Would you agree? Okay, perfect. Good. So I do have a little bit of a problem here because this is the function, this is one variable, and this is the other variable. So somehow I have to get rid of one of these two variables, and let's say we want to get rid of y. But how do I get rid of y? I have to use what I have. I will solve this equation for, but I want to solve for y because I want to eliminate y. So then y will be negative x plus 16. I move x to the other side. Then I will replace y in the formula for the product. So now I can say the product will be a function only of x, and that's what I need. So what function? Can anyone give us the function of x that represents the product? Yes, so let's write it first. Perfect. Let's write it first by replacing y and then distributing negative x squared plus 16x. Perfect. So then, now I see that I have a function that is what type? Quadratic. I know now that I'm asked to find the maximum of this function. I have to ask myself, does this function have a maximum? How and why? Because the leading coefficient, notice that I presented in descending order so I don't make a mistake. The leading coefficient is -1, which is less than 0. So the parabola or the quadratic function has a maximum. So I know that this is quadratic. I know it has a maximum. Now the question is, how do I find the maximum? What do I need to calculate? The so-called, what is the name? Vertex. So we have to find the vertex. How do I find the x-coordinate of the vertex? Indeed, -b/2a. Negative is in front from the formula. How much is b in this problem? 16. How much is 2 times a in this problem? -2. So then the answer is 8. So x is 8. So let's come back here for a moment. If x is 8, how much is y? 8 indeed. But this is not the y value. This is the maximum product. But this is the y, the second number that we picked. Right? We used y. Not to be confused with the y coordinate of the vertex. Totally different thing. So if x equals 8, from here we know that y equals 8, and this must be the product. Or you can say, that's okay, I would like to replace 8 in here to find the y coordinate, which is fine. But remember, the product is x times y. If I have x and if I have y, what will be the product? Which is 64. Or you plug in 8 in the function, and you will get guaranteed the same number. So when you look at this function with a maximum at 8, do not try or consider or think that if you say, okay, let's increase x. If you increase x to 10, you are not going to get a maximum product. You only get a maximum product when x is 8. If you say, okay, let's increase it even more, okay, it's going to be here, then that's not going to be the maximum product. So there is only one point that gives the maximum product, when x is 8 and the y coordinate is 64. Yes, please.
So the y of the vertex is
The-
the product of x, y?
Yes, because that's the function we created. Yes. So the answer to the problem is the maximum product is 64 of two numbers who add up to 16 when x is 8 and y is 8.